Hello everyone, welcome back to my channel. So in this video we'll solve some of the previous gate problems based on RH criterion. Okay, so in the first problem, so he has asked to find the range of k value for which the system becomes stable, and he has given one SFG here. Okay, signal flow graph is given for you. Okay, so first of all, from the signal flow graph we have to find the transfer function. So from the flow graph we have to find the transfer function, and from the transfer function we can find the characteristic equation, and from the characteristic equation using RH criterion we can find whether we can find the value of k for the system to be stable. So when system is stable we can find the k value. Okay, so from SFG you have to find transfer function, and from transfer function by taking denominator you can find characteristic equation, and based on that characteristic equation using RH criterion you can you can find the k value when the system is stable. Okay, so this is the procedure, right? So from the SFG we can find the transfer function. So forward path only this one, so this is the only forward path which you have. So it will be k into S inverse divided by 1 minus, from the Mason's gain formula, 1 minus loop here. So loop gain is, so this is one loop, this is the first loop which you have. Okay, so loop gain is 3 into S inverse, and second loop is this one. So this total is the second loop, right? This total is the second loop. So k into S inverse into minus 1. So k into S inverse into minus 1 is minus k S inverse. Okay, so this is the transfer function. So k into S inverse divided by 1 minus 3 S inverse plus k into S inverse. Okay, so multiply by S, numerator and denominator. If I multiply by S, what will happen? So it will be k, because S into S inverse becomes 1. S inverse can be written as 1 by S, so it will be 1. So this and this gets cancelled out. So S into 1 is S minus 3, S into S inverse is 3 only. Okay, because S into S inverse is 1 again, plus k. Or what can we write? K by S plus k minus 3. This is the transfer function. This is C of S by R of S. This is what transfer function we have obtained. So from transfer function, by equating denominator to 0 we'll get the characteristic equation. So characteristic equation is given by k plus S minus 3 is equal to 0. K plus S minus 3 is equal to 0, or you can write S plus k minus 3 is equal to 0. Okay, so this is the characteristic equation. So from characteristic equation using RH criterion, so RH criterion if you use, what will happen? So odd power of S is 1 and power 0 is k minus 3. Only 2 rows will be there because the characteristic equation is of order 1. So for k to be stable, so this is positive. When this is positive, so for stability only one column is present here. So one column is present whose values of first column are 1 and k minus 3. So 1 is a positive value. 1 is a positive value. So when 1 is a positive value, when given that the system is stable, becomes stable. So when system is stable, then find the range of k he is asking. So given that system is stable, for system to be stable, first row of the first column of the Routh array should not have any sign change. So when this is positive, this also will be positive, then only this has to be positive, then only the system is going to be stable. So when k minus 3 is positive, we can write k minus 3 is greater than 0, and that is k is greater than 3. So for all the values of k greater than 3, system is stable. System is stable. So these are the values of k. This is the range of k for which the system is said to be stable. Okay, so this is how we can solve a problem if an SFG is given. So SFG is given, so first find its transfer function. From transfer function find the characteristic equation by equating denominator to 0, and then construct the Routh array and use the points which I have told you. Then you will get the range of k value. Okay, so we'll see the next problem, second problem here. So in this problem he has given an open loop transfer function of g of s and said that it is a unity feedback system, and he has asked to find the value of k for which the system just becomes unstable. Okay, so here there are some points to be remembered. First is system just becomes unstable, that is, it is about to become unstable, is that means the system is said to be marginally stable. It is about to become unstable, so that is why it is a marginally stable system. So whenever you see the word system just becomes unstable, so you have to think that it is a marginally stable system. And second thing here is, for a third order system like this, as cube plus bs square plus cs plus d is equal to 0, so the conditions you can directly remember. Okay, if BC is greater than AD, system is stable. Okay, so these are the conditions which you have to remember. So if the coefficients here B into C, if you multiply, and if that value is greater than the coefficients of these two, AD, so system is said to be stable. Next, BC is equal to AD, system is said to be marginally stable. Okay, third, if BC is less than AD, system is unstable. Okay, so this is again obtained from RH criterion only. S cube, if you write A, C here, S square, this will be B, D, so S power 1, so this will be BC minus AD by B, and S power 0 is D. So ABD are all, if ABD are all having one coefficient, that is all positive, let us take that all positive, then BC minus AD must also be positive. So if BC minus AD by B is greater than 0, so what will be the condition? BC is greater than AD. Okay, so that is what I have written here. If the condition again here is A comma B comma D are positives, A comma B comma D are positive, and BC is greater than AD, then the system is said to be stable. If BC is equal to AD, when BC is equal to AD, then what will be this? 0. A row of zeros occur, right? A row of 0 occurred. When row of 0 occurred, it is marginally stable system. Okay, poles on imaginary axis. And if BC is less than AD, so if BC is less than AD, this becomes negative. When there is a negative sign, then there will be sign change. When there is sign change, it is an unstable system. Okay, just remember these three concepts. Right, so coming to question here, first of all we need to find the characteristic equation, which is 1 plus g of s into h of s is equal to 0. So 1 plus g of s is k by s into s plus 2 into s plus 4 into 1. H of s is unity feedback system, into 1 is equal to 0. So this is s square plus 2s into s plus 4 plus k is equal to 0. So it is s cube plus 4s square plus 2s square is 6s square plus 8s, right, plus k is equal to 0. Okay, so this is now of this form, right? This is of this form: as cube plus bs square plus cs plus d is equal to 0. Okay, so he has given that system is just becomes unstable, that is system is marginally stable. When system is marginally stable, this is the condition: bc is equal to ad. So here a is equal to 1, b is equal to 6, c is equal to 8, and d is equal to k. Okay, so if you see here, a b values are greater than 0, a b values are greater than 0, that is why we can use this condition. Okay, so BC is equal to AD. So when you find BC is equal to AD, so B into C, that is 6 into 8 is equal to AD. AD is 1 into K. So 1 into K is K. So that is marginal value of K. So K marginal is equal to 48. This is how we can solve this question. Okay, so remember these 2 points, that is very important. Okay, so if the system is just becomes unstable, means it is marginally stable, and if you have the equation of this form, just remember these 3 you can solve directly. Okay, right, we'll see the third question here. Right, so third question, so find the values of k and b so that the system with transfer function this and feedback oscillates at a frequency of 2 radians per second. So this is the question given for you. So how to solve this? So first of all, you have to find the characteristic equation. So characteristic equation is given by 1 plus g of s into h of s is equal to 0. So 1 plus k into s plus 1 by s cube plus bs square plus 3s plus 1 is equal to 0. So s cube plus bs square plus 3s plus 1 plus ks plus k is equal to 0. So denominator, if you send that side multiplied by 0, so it will also be equal to 0. So s cube plus bs square, right? So from these 2 terms, 3s and ks, you can take s common, so it will be 3 plus k plus 1 and k, both are constant, so it will be 1 plus k is equal to 0. Okay, so if you observe a is equal, so I have told you in the previous problem, a is cube plus bs square plus cs plus d. So a, b and d are greater than 0. Since you can see a is greater than 0, so we can assume that b and d are also greater than 0. So the second point which you have to remember here is, so you have to remember this concept, that is using this third order equation, how to use this third order equation, and oscillates at a frequency of 2 radian per second. So what he has given is it oscillates at a frequency, constant frequency. So constant frequency and amplitude of oscillations is obtained when the system is marginally stable. Marginally stable. Okay, so marginally stable, then only the roots will be, the poles will be on imaginary axis. When poles on imaginary axis is there, then only we have constant amplitude and frequency of oscillations. So whenever you see the word oscillates with a frequency of 2 radian per second, so such type of wording, that means the system is marginally stable. Okay, so he don't give you directly the system is marginally stable, but gives you this word, oscillates at a frequency of. So if a system oscillates at a frequency of 2 radian per second, that means it is producing constant frequency of oscillations, then we have to know that it is a marginally stable system. When the system is marginally stable, what is the condition I have told you? BC is equal to AD. BC is equal to AD. So here A is equal to 1, B is B only, and C is 3 plus K. Okay, so comparing with this standard form, if you compare this equation, so A is equal to 1, A is cube, so A is equal to 1, BS square, B is equal to B only, CS, that is 3 plus K, C, and D is 1 plus K. So BC is equal to AD, so B into C is 3 plus K is equal to A is 1 into 1 plus K, D is 1 plus K. So what can we write? B is equal to 1 plus K by 3 plus K. Let this be equation number 1. So when it oscillates at a frequency of 2 radians per second, so what does it mean? It means a marginally stable system. When a marginally stable system is there, you should have the frequency of oscillations, that is auxiliary equation. Yes or no? Row of zeros occurred once, row of zeros occurs once. So when can the row of 0 occurs? Only in odd powers of S row. Odd powers of S row. So S cube cannot be 0 because S cube is the starting one, so starting row. So what we have is S power 1 is the only option. S power 1 should be a row of zeros. then s square here it should be a this should be the auxiliary equation, and the roots of auxiliary equation represents the closed loop poles. Okay, so let me write this, construct the Routh array. S cube is there, s cube 1 and 1 plus k, s square b, sorry here it is 3 plus k, sorry, b and 1 plus k, and s power 1 is 3 plus k into b minus 1 plus k into minus 1 plus k divided by b, and s power 0 is 1 plus k. Right, so if the system is said to be marginally stable, this should be row of zeros, and this becomes your auxiliary equation. So what is auxiliary equation? S square plus 1 plus k is equal to 0, s square is equal to minus 1 plus k, s is equal to plus or minus j root of 1 plus k. Right, so this is b, no, so b s square plus a, so this will be by b, so it will be 1 plus k divided by b. So this is your omega n, so this is your oscillating frequency, plus or minus j omega n, so plus or minus j omega n. So omega n is equal to root of 1 plus k by b, so this is given as 2. So squaring on both sides, 1 plus k by b is equal to 4. Let this be equation number 2. So from 1 plus k, so from this equation 1 plus k by b is equal to 3 plus k. Yes or no? So again 1 plus k by b is equal to 4 we have got, so 4 is equal to 3 plus k, so k is equal to 1. So when k is equal to 1, what will be the value of b? B is equal to 1 plus k by 4. So 1 plus k is 1, so 1 plus 1 by 4, which is equal to 2 by 4, which is 1 by 2. So therefore we have got k is equal to 1 and b is equal to 1 by 2. Okay, so this is how we can solve an equation of third order very easily. Okay, so let me take one more slide. I'll explain you the concept of this third order equation very clearly. Okay, so when you have a third order equation like this, as cube plus bs square plus cs plus d is equal to 0, and you construct the Routh array, so a c s square b d, and s power 1 is bc minus ad by b, s power 0 is d. Okay, so a comma b comma d are greater than 0, and if bc is greater than d, so this becomes positive. When this also becomes positive, there will be no sign change in the first column, therefore system is stable. So for this condition, system is stable. When bc is equal to ad, this becomes 0, so 0 rows will occur. When 0 rows occurs once, then system is marginally stable. This we have discussed, right? So system is marginally stable when row of 0 occur once and there are no sign changes, because when bc is equal to 80, this also becomes positive. Okay, this becomes 0, b0 is also a positive value, so no sign changes, and row of 0 occurred once, so that is why system is marginally stable. When bc is less than ad, system is unstable. Okay, so when bc is less than ad, this becomes negative. When there is negative, so there will be sign changes, so system is said to be unstable. So in this case, in marginally stable case, then auxiliary equation considered here is bs square plus d is equal to 0. So bs square is equal to minus d, s square is equal to minus d by b, s is equal to plus or minus j root d by b, plus or minus j root d by b. So this represents the equation. Okay, so this represents the omega n here, that is natural frequency of oscillations. Natural frequency natural frequency of oscillations, because when system is marginally stable, the output will be constant amplitude and frequency of oscillations. So this represents the frequency. Suppose if you have suppose s square plus 1 is equal to 0, s square is equal to minus 1, s is equal to plus or minus j1. So this 1 represents here the natural frequency of our oscillations, that is 1 radian per second. So generalizing this case, this is the natural oscillations. So in the previous case also, what you have is bs square plus 1 plus k is equal to 0 you have. So s square is equal to minus of 1 plus k by b. So s is equal to plus or minus j root 1 plus k by b. So that is why there I have taken omega n, which is given as 2, is equal to 1 plus k by b under root. Okay, so it becomes 4 is equal to 1 plus k by b, and from the other equations you can solve the values of b and k. Okay, so this is the concept here. Then only it will then the frequency of oscillations will be constant. So that is why it is called as natural frequency of oscillations. Okay, so s are plus or minus j omega, s is equal to plus or minus j omega form. So this is omega n plus or minus j omega form. So it is your natural frequency, which is omega n. So here also s is equal to plus or minus j omega form. So this is your natural frequency generalized equation. So if you apply in the previous question, you will get like this. Okay, so I hope now you have a clear idea of how to solve a third order equation. Okay.